And we are live, I believe. So welcome everyone. Welcome to another Amplifying F#, the Essential Lectures. This is an ongoing course that we have been running for the last 7 weeks, I believe now. I'm a little bit lost. We have done so many weeks already. And we continue learning F#. We continue getting deep into the essentials of F#. And just a little bit of reminder, last week we cover processing external data. So if you couldn't, if you didn't attend to that lesson or you couldn't yet check the YouTube video, please come visit to amplifyingf#.io as F# Essentials, and on here we already uploaded the video on our YouTube channel, and you can also watch it here. So yeah, it's available now. But for this week, we have more pattern matching, where Ian is going to take us in a journey to go deep into pattern matching and learn more about something that is a fantastic feature called active patterns. So yeah, we will be covering today this. So without further ado, I will give it to Ian, and we can start from there. Bear with us with a second.
Just need to share my screen.
Yep, should be good. Yep, I can see it.
Okay, marvelous. Right, so welcome to session 7. So this should really be called even more pattern matching, because we've been doing pattern matching pretty much all the way through, because it's very much a core part of the language and the way of working with F# as well. I'm going to do a very quick recap on session 6, but I'm not going to actually show any code. As Edgar said, if you want to see what happened in that, go back and have a look at the last session of the video for that. So we basically looked at external data. F#'s fantastic for processing external data, whatever it happens to be, whether it's SQL, JSON, XML, CSV, you name it. There is a library or a set of libraries out there. You can use a lot of the stuff from the C# community as well, although it's a little bit harder to use because a lot of it relies upon things like reflection and objects and mutation, and they're things that we try to not encourage, or things that I try not to encourage anyway. And obviously things like entity framework is a no for most people. I recommend not touching it, but there are lots of tools out there for you to play around with. We also had a quick look at anonymous records as well. So particularly when you're outputting in an API or a website, and you're outputting JSON in particular, but it's useful for everything. But for JSON, it's really useful because you can define the output that you're going to work with, but without actually specifying it before you use it. So you don't have to create a type. So you can just create an anonymous one that has a different shape, and that works really well. We also looked at type providers, and I said that there were 2 types, so generative and erased. Generative produces actual types that you can then actually compile, put into a library and use anywhere. And then you've got erased, and they're basically created at runtime. And all the interesting ones I looked at inside of F#.data are erased types, so you can't use them in other languages. So they rely upon data that's available at runtime to work. And I didn't cover it, but there is an Azure storage one as well, that type provider that works with tables, blobs, and queues. So that's it for session 6. Session 7, we're going to be talking about active patterns. So, as I said, we've covered a lot about pattern matching already, and it's it's pretty much all the way through most of the F# code that you'll use. But everything we've done so far is based on the built-in pattern matching system. So there are probably, I think we've covered 15 or 16 different types. I'm not going to go through them, but we've covered all of the matching lists and discriminated unions and everything else. So there are 15 or 16 that we've covered already. But there's an interesting thing that's been built in for a long time called active patterns. And what that allows you to do is to basically write your own. So it might sound a little bit odd, but it's a really interesting idea. Oh, it's not an idea; it's an actual thing that you can do. So there are two types of active patterns. There are partial and total, and the difference between the two is really that partial active patterns, they apply to a subset of the input data, whereas total active patterns will always will apply to every single possible value that's sent in. So rather than talking about them, let's go and have a look at some. So we're going to start off with a simple idea. This isn't an active pattern at the moment. So we're going to parse a string and make it a date time. So I've written a simple little function here that takes a string. We then do a basic pattern match on date time using the try parse, and that produces a tuple which returns a Boolean and a value. So we pattern match that. We get true or value for if it's okay, and we return some value from that. And if it's not, we return none. Which is fine, but we can't reuse this. We can reuse the parse function, but we can't reuse the pattern match. So what I'm going to do is create a simple partial active pattern to that we can reuse. So the structure looks really odd. It's in parentheses and bars. So somebody said that looks like a banana. So they're affectionately known as banana clips. So the parentheses and bar, because it sort of looks like a banana if you look at it. So I'm going to put in date time. And in this case, I've got a wildcard as well in there. So this is the partial part. So what I'm going to do is I'm going to send in an input of string. So this is going to say when I do my pattern match, it's either going to be a date time or it's not. So this is, as I said, this is the partial part. So I can copy the pattern match from here. So a partial pattern match will always return an option, and it can either return a value on the happy path, so the sum path, or it can return nothing. In this particular case, because I'm doing a parse, I want to return the parsed value. So that's why you've got the value here. If I didn't want to return a value, then I can return unit. And we'll have a look at one of those in a minute. And then obviously on the false path, we return none. So let's have a look at what we've got here. So if we do, so instead of pattern matching against in the parse function, instead of pattern matching against the date time, I'm going to pattern match against the input. I'm going to go date time and nothing else. So this is me saying that is going to be a date time. So pattern matching in this particular case is saying if it's a date time, extract the value, and then I can return it. So if I run that in interactive in FSI using Alt and Enter, it should tell me that the bad is none. And the good one is a valid date. So that's a partial pattern. So let's think about one that wouldn't return a value. If I'm not interested in the value and it's returned, I can use the wildcard. What could I use for a partial? What could I use for one that didn't return a? Actually, I have a really good example, but I need to cheat a little bit. Wrong one. Sorry, I'm trying to find my. Can't believe I've got it. Oh, I've gone and got rid of it. Don't believe that. Oh no, I haven't. Right, so this is. So I'll just copy this one over. Sorry about that. Right. So this is regex, but the one that I want to look at is the email case. So with email, I've got I'm passing in the input. I'm doing a parse of regex. I'm just returning the input. I probably don't even need to return the input. I could return unit in that particular case because I already have the input because I've passed it into the function. But in this particular case, I've decided to return it. So again, parse regex and email are both partial active patterns, although parse regex is actually slightly different because parse regex is what they call a parameterized partial active pattern. Yes, I did say parameterized partial active pattern. So the difference between a partial active pattern and a parameterized active pattern is that there's an extra parameter passed in. So the thing that you're testing, so the thing that you're actually pattern matching against is the last parameter that's passed in. And if you have another parameter, then that's passed in before that. So this is a parameterized one. It's exactly the same. One, you can have one value and that's so it either matches or it doesn't match. So it will always return an option of something. So parameterized partial active pattern. I'm going to do fizzbuzz for this as an example. So I think we all know fizzbuzz and input. So let's just get it going first. So if I do So input percentage 3 equals 0. So if that's true and true, it returns fizzbuzz. If it returns true and false, returns fizz. If it returns false and true, we get buzz. And otherwise it returns the string of the input. Okay, so perfectly readable. Maybe not. What I want to do is to try to improve this a little bit. So what I'm going to do is I'm going to create a parameterized partial active pattern that does the division. So I create my banana clips and I'm going to go is divisible by, this is a partial, so there's a oops, is divisible, that's close enough. So I'm going to pass in the divisor and then I'm going to pass in the value. So if input percentage divisor equals 0, then sum. So I'm not interested in the, I know it's 0 anyway, so it's divisible. Else return none. Let's do a copy of that. Cut it out. Right, so what I want to do is I want to do this as, so now I'm just going to match the input. I'm going to say is divisible by 3. And we can actually combine these together, so I can do and is divisible by 5. And this one's just is divisible by 3. That is divisible by 5. The rest doesn't matter. So we've got there a nice little set of patterns that works reasonably well. Problem with this, although it's slightly more readable for me, I don't know whether you agree or not in this particular case, but I find this more readable than the original version. It's not very extensible. So if I added 7 on there, I suddenly jump from, I've got one that has, so if I have 3 5, and 7. I've got one line that goes 3, 5, and 7. I've got one that goes 3 and 5, one that goes 5 and 7, one that goes 3 and 7. And then I need to cover 3, 5, and 7 individually. And I need to make sure that I get them correct. And that starts to get a little bit difficult to manage. So one of the things we can do is change the logic a little bit, so that rather than passing them in individually like this, we pass in a list of values, which should make it a little bit easier to read. So if I change divisor to a list, so what we're now going to say is that so list dot, one of the functions available in the list module is for all. Oops. Should be divisors. So that's my div. So I need to say each one, I need to say input mod equals 0. Okay, so I can now change this and make it a list instead. Okay, I can quickly test that. Well, I don't know about test, but verify that it looks reasonably okay. So if I do a list.map, make sure that's interactive, and then run that. That looks reasonably okay. So there. So we've got any questions from the first part?
Yeah, we have one question about if we could use the double ampersand when you are evaluating multiple acting patterns. Let's say, for example, before in the previous sample you have is divisible by 3 and divisible by 5.
No, you can't use the double ampersand. We've actually used the so this is it's a little bit odd because you use the, if you have a when guard clause, you use the double ampersand in the when guard clause, but you don't use it for combining patterns together. Combining patterns together, you use a single ampersand. But the interesting part about that is we've already been using or quite a lot, because or is a single bar. So we've already had examples through these sessions where we've already been using the single bar for or anyway. Yeah, so it is different. You can't use double ampersand. If I which one did I do that on? Oh, there's a previous example. I've got rid of it, haven't I? Okay.
Yeah.
But I could still do it again. So if you try the double ampersand, you actually get a compiler error. So yeah, it's a single ampersand for pattern matching. And then a single bar for or.
Which leads me to believe that we can do better in the compiler, maybe to recognize that you are using active patterns and you should use one rather than two and be a little bit more smarter there. But yeah, that's a different story. I will try and
Yep.
see if I can raise an issue so we can have a better message.
Was that the only?
Yep, that's the only question so far. And I also linked in the chat the docs for the active pattern, so in case someone wants to read that.
Okay, so they're the two types of partial active patterns. So we have a partial active pattern and a parameterized partial active pattern. They're probably the ones you'll use most of the time. So the other types that we have are called, well, they're not actually called not partials. Most people describe them as total, but that's not actually in the name. So what you actually get is we have a single case total active pattern, but it's just generally called a single case active pattern. And we get a multi-case active pattern as well, which is a total one. So this example here of character count, you'll notice there's no wildcard and extra thing there. So for every input, so for every string, there must be a valid value that comes out. So in this case, we've got character count. I send in a string and it just returns the length of the string. And the one underneath contains a number. So this looks at the string and then returns a true or a false in this case. So if I want to write a little function that says that a password must be at least 8 characters in length and must contain at least 1 digit, what I can do is I can actually use active patterns inside other active patterns. So we've got two single case active patterns here. So character count and contains a number, but then we're using them inside a partial active pattern, which is the invalid password. So if I pass in a string, we'll do a pattern match on it. And the first thing we'll do is we'll check the character count. And to get the value out, we can access the value directly. and then add a guard clause to say when less than 8. In this case, I'm returning the negative, so I'm checking for things that will fail if it's a bad password. So it must return at least 8 characters. And then if it doesn't contain a number, again, we'll return something, otherwise it returns none. So then when we use it inside a function, we just check for the whether it's an invalid password and obviously return the error message. So this is a single case active pattern, and this is a total one. So as I said, the difference between a partial and a total is totals don't have the underscore, the wildcard. So there's always going to be a valid value returned. Whereas the partial case, it may have a valid value or it may not. And obviously I could run those. Right, so multi-case total active pattern. Simplest one that I could do here would be something like odd and even. So again, we get our banana clips, and I'm going to go odd, even. I'm going to pass in an input. And here I'm going to go, so if input 2 equals 0, then even, else odd. So what we're returning here in the multi-case active pattern is we're returning the cases. So we're not returning an option or anything like that. We're returning the actual cases that are in the active pattern itself. So odd or even. So any input that you use, there will be an output that's in those examples, in those cases. And then to use that, let's do is odd. Getting there eventually. Right, so match input with odd, and we'll return true. Return false. Okay, so that's a multi-case active pattern. It might seem really simple. So something like you'd think you'd be able to do something like I don't know, pass the month in and get the season. So but we do something like that. So we do spring, summer. I'm going to do it. I'm obviously English, so this is going to be autumn rather than fall. Match input with So if I go 1 or 2 or 3, we'll return spring. 4 or 5 or I know these are not strictly when this happens, but it's close enough for our needs. Okay, unfortunately, this doesn't work with it being strict like this. So it says that it's an incomplete pattern match because obviously there are more ints than there are 1 to 12. So either we could so an obvious thing is, could we make it a partial? The answer to that is no. You can't have a multi-case partial active pattern. There was talk about it at one point, but it's they decided not to do it because the way to get around it in this particular case would be to have a specific case here, which would be unknown. So, and obviously I'm not covering all of the cases at the moment. So the idea of a multi-case is that that you will return every single one of the cases from one of the routes through the pattern match. And it can't be, you can't have a multi-case that's partial. So you'd have to have if you need it, you'd have to have an end value which covers all the cases that aren't covered directly. If that makes sense.
Yep.
Okay, any questions from that one?
Yeah, we have an observation and a question. The observation is, wouldn't it be better to call these custom patterns rather than acting patterns? And my answer was that naming is hard. So I really don't know the answer for this. Do you know what's the the meaning of acting patterns? I'm more like maybe etymological
I
answer.
don't. I don't. I do remember I watched a video a few years ago with Paul Blasucci, who
Yeah.
talked about there was a paper that Don Simon, a couple of other guys from Cambridge Research did, and I think
Um,
the entomology for active patterns is probably in that.
I think I know where it is. I'm going to try to find it while you continue with the lesson, and then I will try to link it in the chat. Right, and the last one is instead of one bar, two bar, three, can we write a kind of a list that goes from 1 to 3? I don't think that's possible, isn't it? Like a how's that called?
A list,
Like
well, be a list comprehension. No, you
yeah.
can't. You can't do that. You can do. There also aren't things like greater than and less than. So there are things built into the switch expression for C# that allow you to do things like greater than 1 and less than 3, that sort of thing. So there's nothing like that built in.
Yep.
It's just not really necessary. often you find that if you've got a when clause, that often helps anyway. But it's not perfect. The idea really of these sorts of things is to hide the complexity behind the active patterns. So the active patterns actually are more business focused than the code that you would originally write. So you'd never need to look at this sort of thing normally. You just pattern match on the active patterns, and that hides some of the complexity away for you. So if I so that's so they're basically the four core active patterns that we have. So we have a partial active pattern, we have a parameterized partial active pattern. So partial is again, it's not all the cases are covered. So if you pass a string into something that wants to convert to a date time, not all strings can be converted to a date time. And then parameterize just allows you to add extra parameters to send extra parameters into the test. And then you get the total active pattern. So you get single case total active pattern. And in this case, they have to return a valid value rather than an option. And then you get the multi-case active pattern, which has to return one of the cases at some point. If it doesn't return every case, so if I make that one even as well, the compiler will actually tell me that I'm not using all of the values. So you actually have to use all of the values in the definition. But then when you come to use those patterns, the compiler is clever enough to know that you've covered all the cases. So that was a quick whistle stop tour through those. So let's have a look at actually trying to use some of these to help us a little bit. So the first one I'm going to look at is so this is an example of one of the modeling things that we did in the first session. So this is modeling 4. It doesn't matter which one of these that I used. What I want to do is I want to simplify this this pattern match here a little bit. In particular, I want to simplify this part. So although there's not a lot there, you've still got to look at it and think, what does that actually mean? So what I'd like to do instead is to make it so that I can make this pattern match a little bit cleaner and just make it more understandable at a glance. So what I'm going to do is create in this case, I'm going to create a partial active pattern because not all the data is going to work. So what I want to say is what I'm actually saying with this. So I'm saying that if they're registered and they're eligible and they spend greater than that, so how about we call this qualify for discount instead? And then because this is partial, I'm going to add the wildcard in as well. And I need both bits of data, so I need to pass in the customer and the spend. So let's so I'm do a match inside this. I'm going to do exactly the same as, so I could just take that. So I need to match the customer. And I'll put it in as unit at the moment. But I might come back to that. So I passed in the customer and spend, and I've then used the pattern match that I used that was in there earlier to return that. So what I can now do is I can get rid of all of that and replace it with that. And I need to add spend into there as well. And so I'm passing the tuple of customer and spend into this active pattern, into this partial active pattern. And because I'm returning sum of unit, I don't need to specify anything in the value here. If I wanted to, I could have returned some form of calculation. So I could have returned that. That means that simplifies to that. So as I said, part of the one of we use active patterns for all sorts of different things, but this is one of the nicer things in terms of things like domain modeling. So you can hide complex logic that you're going to have to write somewhere behind something that's more business focused. So if you need to understand why they qualify for a discount, then you can look inside the active pattern. But most of the time, you won't want to look at that. You'll just want to know at a glance what this is. And that is definitely more readable for me. Let me quick. Okay. So that's one of the uses that we have for this. This is a slightly modified version of the code that's in my book in the active patterns directory. So I'm going to do the football score predictor. So this again is football as in the game that most of the world plays, where people kick a spherical ball with their feet. So the way that this works is that if you say for any particular match what the score is going to be. So whether it's going to be whether somebody's going to win 1-0 or draw, etc. And then you compare it against what actually happens. So if you guess the exact score, you get 3 points. And if you guess the result, so whether it's a draw, a home win, or an away win, you get 1 point. Otherwise, you get Nothing. So I've created a little type here, which is just a it's a tuple with 2 ints. So there's a home goals and an away goals for each one. And then we're going to create we've got a little function here called calculate that takes my guess, which is the score that I'm guessing it's going to be, and then what it actually turns out to be. And I'm just going to return 0 at the moment, but I'm going to actually do some pattern matching here to get this to work. So let's have a think about how we'd calculate this normally. So let's match on the guess and the actual. Okay, so the guess is a tuple, and what I'm going to do is I'm going to call so my first case is the exact match. So I don't need to decompose the guess and the actual. I can actually just compare. I can just compare them because we can compare tuples for equality. So if I do for any case when guess equals actual, then we'll return 3 points. Okay, so if I run that hopefully that correct score this little helper test should work. So the next case is we've got three examples. So when the results are the same, so there's a draw, a home win, and an away win. So I need to decompose the tuples into their constituent parts. So I'm going to call this guess home and guess away, and then actual home and actual away. So so this is a draw. So this is goal home equals guess home equals guess away, and actual home equals actual away. So that's a draw. A home win is when the home score is higher than the away score. And then an away win is when the home score is less than the away score. It's got to match on both sides. Right, let's just run all those just to make sure. Okay, so that looks correct. So I've got the correct results. Yeah. So this is pretty horrid as a bit of logic. There's not much there, but it still takes a little bit of thought and a little bit of effort to get it to work. So what we're going to do is is make this easier to read with some active patterns. So let's start with the correct score first. So let's correct score. This again is a partial active pattern. And I'm going to take a tuple of the scores in. Okay, so this is quite easy because it's just if guess equals actual, then I return sum. I don't need any value in this particular case. Else none. Okay, so I can now replace that correct score with correct score. Okay, let's run all of those, just check that they work. Yep, that's still okay. So now the next one, we've got, I need to determine whether they are, whether it's a correct result. But to do that, I need to look at each individual score and work out whether it's a draw, a win, or a lose, a draw, a home win, or an away win. So let's do the draw, home win, away win first, and that's going to be a multi-case active pattern. And I'm just going to pass in a score. I'm going to match the score with. Okay, so this is, I need to decompose it. So that's home and away. So when so if home is greater than away, then it's a home win. And if it's not either a draw or a home win, then it must be an away win. And now I can do my correct result. So if I copy that, so this is correct. So what I need to do here is to compare the guess and the actual. So match so if I go draw, comma, draw, and actually I can If it's a home win and a home win, and that's saying if they're both draws, or both home wins, or both away wins, then that's a correct result. Otherwise, it's not. So now I can replace all of that. Oops. With correct result. Now, I don't know what I changed there, so it's just easy to do all of that. And that all works. So I've simplified that horrible bit of logic that we had with something fairly simple. So we've hidden some of the complexity underneath the active patterns. But what we actually look at is much easier to understand and much easier to reason about. Any questions on that?
No, really. There are more observations about if you cannot do something like Prolog does, but I don't know what Prolog is, to be honest. So I'm not going to. And do you know uh, if there are built-in active patterns to basically check some of the usual stuff that we do in F sharp? So maybe that we can be aware of.
In what way?
In a way, maybe to, for example, compare that two values are the same. I don't think there is, let's say, a built-in active pattern matching, active pattern that can be checked if two values are the same.
I don't think so. You could create your own.
Yes, exactly. Yeah, you can create your own to check that.
I mean, the whole idea of this really is that it's you've got a basic set of built-in things that you can use, but then this is basically as extensible as you like. So you can push it
Yeah.
as far as you want to go. It's not a perfect thing. It doesn't solve all the world's problems. It just as long as you use it sensibly, it does clean your code up considerably.
Yeah, you can also make it recursive and you can do all of that stuff, but that's not, something that we want to do right now as we are starting with F sharp. So, but yeah, if someone wants to dig more or investigate more, there can be value types, they can be recursive, and you can make them tail recursive as well. So yeah, there are different more things that you can extend with this.
Yes, but it's just getting used to doing it. It's
Yeah, makes
just
sense.
whenever you see a complex bit of logic, often you'll find that an active pattern will tidy this up for you no end.
Yeah.
Right, so that's you can see there where that you can reuse um, active patterns, so you can use active patterns within other active patterns, and that works really well. So that's complex bits of logic that we had there is suddenly much simpler to reason about. Right, so the last example that I'm going to cover is this one, and we're back um, on our list of customers again. So this customers.csv, I'm not going to load it in this particular session, but we're going to. So this is almost a precursor of what we'll be doing next week when we do validation. So this is I'm just going to load some of the data that we've got in that customer.csv file, but I'm just going to load it through as text at the moment. So I've created a simple type that contains name, email, is registered, is eligible, date registered, and discount. So it's exactly the same as that's on the that's in the CSV. So we've got a name, an email, eligible, registered, etc., etc. So I'm shifting stuff around a little bit. Right. So we've got that. I've created a little helper function as well called create that takes all those values and creates a customer for me. I'll come back to these in a second. And then I've got a simple parse function as well. So it takes a string, we then split the string based on the bar, and that obviously returns an array, and we pattern match on the array based on that it splits into 6 items, and we then extract the values out from those, and they come out as name, email, etc. And then we pass them into the create method, and then I create I copy the string for one of those people, and then I parse it and just check that it returns a customer. Okay, so, and obviously this will work as is, but some of the data that we've got here isn't, I mean, it is a string, but it's not. So we can actually do some pattern matching here with active patterns to get some of this data out as typed data rather than as a string. So let's start off. I'm going to start off with the email. So I've already created a little partial active pattern called parse regex. Sorry, this is parameterized partial active pattern because it's sending in the regex pattern, and we pass in a string and input, and then we're doing some matching. And the reason for the tail on this is that we throw the root one of these away, so it just returns all of the remaining groups. And then we've got the email here. So, and I'm just reusing the parse regex. I pass in a little bit of regex text, and I'm actually throwing away the result in this particular case because I know that if it goes through that line, that actually the input that comes in is a valid email. Well, it's a valid email as far as that regex is concerned. Obviously, it's not perfect, but it's just a simple example. And so what we can do here is, rather than returning a string, what I can do is I can say that this has to be an email. So if I run this, I'll find out all this text. What I end up with is that when we parse John, we find out that John is created because John is an email. So if I create another one here called Fred, and make it so that it's not an email. Okay, so just run those. It tells me that it's an invalid input row. So by pattern matching, by using an active pattern like this, we're actually being more explicit about the data that's in there. So we are actually matching a pattern. So this must be an email for it to work. So we can push this further. So we know that the date registered is a date time. And in fact, I have one of those already somewhere. So if I say that has to be a date time. What I can also do, and this isn't, and of course now I've now got a compiler error because now this is returning a date time. And obviously my create function doesn't take a date time. So if I go to my create function, so my create function still thinks it's a string because that's what the customer wants. So if I turn that to a date time, let's get rid of my exception. Sorry, my compiler error. What else have I got? I've got a discount there. The discount's a decimal. So another partial active pattern here. And I can do the same, so match try parse. With, again, this is a tuple, it's exactly the same. So return some value and otherwise return none. So again, I've got the same problem. Change that to a decimal. I know that I've got two flags there. So it is registered and is eligible. Let's try. Let's do a Boolean. So it's a string again. So match input with. Well, I've got a 1. Returns some true. A 0 returns Some false, and anything else returns none. Okay, so let's get rid of red for the moment. Let's just roll that and see what happens. Okay, so I've got John. That's an email, true, true, date, time, and a decimal. That's looking pretty good. What else have we got? Well, I probably want the name to be not an empty string. Unfortunately, with active patterns, you can't do negatives. So we actually need to write an active pattern for the negative case. So it'd be nice to be able to do not empty string. So that's what we're going to have to do here. So not empty string. Again, this is a partial active pattern. And in this case, I'm going to just do a simple if statement. So if input not equal to empty string, then I don't care about the value in this particular case. Or do I? Yes, I do. Return input. I can make that a non. Non-empty string. Got there eventually. So that's covered all those cases. So if I just run those bits, because they're the only bits that have changed. Okay, so that's still working. Okay, so the only other thing I want to cover here with this is I want to cover the split function as well. At the moment, this is a separate thing, but we can actually write a little single case active pattern here. So we can do split. We can split it on a particular value, and I'm actually going to convert it to a list rather than an array because it's just easier to read. So what I'm going to do is I'm going to pass in input, and then I'm going to do split. So this again is just showing the power of active patterns. So if you do the whatever it is, the December code things, the winter of code or whatever they're called, often they give you a string to parse, and this particular active pattern is quite useful in those because it allows you to pattern match the you often get a little bit of string and then some numbers and then some more strings or numbers on the end in slightly different formats, and this allows you to just specify that pattern very quickly using that split active pattern. So any questions from that part?
No, I just basically replied to one of the comments that were asking if we can give an example of a recursive active pattern. Just pasted a sample, and yeah, that will answer some.
Okay. So that's as far as I want to go with active patterns today. Then, as I said, the next session is going to be on validation. So we're going to take a lot of the ideas that we've done here, particularly the partial active patterns. We'll use those a lot with what we're doing next week. And thank you very much for watching.
Yeah, thank you, Ian. It was really awesome session. Yeah, it really clicked that to me some of the concepts that I still didn't really understand. Yeah, it was awesome, and yeah, someone said in the comments that your explanation of active patterns is actually really it's much better than what the existing documentation that Microsoft is explaining about active patterns. So yeah, I 100% agree with that. Yeah, with that in mind, let me take back the sharing screen, and we are going to wrap the session with a little bit kind of reiterating again that this is a part of the video part of the F# Essential Lectures. This is an online course that is based on Ian's book, and we have been covering all of these sessions so far. So if you are watching this on YouTube and you want to learn F# and you want to really understand the core language, have a look at this playlist that you will find a lot of useful information. So yeah, as Ian said, next week we will be covering functional validation. And yeah, so with that in mind, I will see you next week, everyone. Yeah, have a lovely rest of the week.